All right, this is Honors Algebra 2 Pre-Calculus. We're doing 6.4 in Algebra 2. This is our third video. We're talking about some old school logs before these lovely graphing calculators like this thing over here. So back in the day, and I mean like way back, before I was in high school, before we'd invented fire or the wheel, I mean a long time ago, kidding. Before there were calculators that could evaluate logarithms, people had to use log tables in books to evaluate logs. The tables had logs of various bases evaluated to prime numbers. So here's a sample of what some of these would look like. Now, if it were actually a log table, and when you look at the log tables, they look very different, and they go for pages and pages and pages. But this is just a small sample of what would happen. See how all of the things inside the logs are prime numbers. 7's prime, 3's prime, 5's prime, 3's prime, 5's prime. And the 8.3 is actually not a prime number, but you get the gist that they gave you this 8.3. And you get a value. For right now, you're not going to worry about where you got this value, but all of these approximate values are handed to you. We're going to use these values to find the values of other logs just to show you how this used to work. Not because it's a skill that you're really going to need particularly at this stage of the game between having graphing calculators and phones that have graphing calculator applications, et cetera, et cetera. But let's walk through how it works in just two quick problems, and that'll be it for 6.4. All right, so we're going to use the properties of logs and this table to approximate each of the logs below. So what they're asking here is they're asking you to use the log properties to change this stuff into stuff from the table. Well, I noticed that 15 is a 3 times a 5. So this is the log base 4 of a 3 plus the log base 4 of a 5 using log properties. Well, both of those show up on the table, right? Log base 4 of 3 is right here. Log base 4 of 5 is right here. So this is going to be approximately 0.7925 plus 1.1610. That's what they want. Now, I'm lazy and I'm not going to do that by hand. I mean, you could, I guess. I guess I could be a less lazy human. Let's do a little bit of mental math. It's not the worst. I mean, it's not fully mental math, but it's just by hand. So if we add, we get this, right? So we get that this is approximately 1.9535. Cool. Notice I'm going to keep all 4 of the decimal places because this is already an approximation and they approximated to 4 decimal places, so we're just going to go with it. The log base 4 of 12, well, 12 is a 3 times a 4. Now, I know it's also a 2 times a 6, but looking at what we're handed, we know information about 3's and 4's. So I'm going to get this is the log base 4 of 3 plus the log base 4 of 4. Well, log base 4 of 3 we already have, right? That's going to be a 0.7925. And this one is a 1 because remember, we have that rule that says that the log base b of b is 1, right? Because b to the first would give you b. So I'm going to get that this is approximately a 1.7925. And again, if you're like, Hogan, why would I ever use this? That's a good point. This is why this is the last video and it's only 2 examples. Here we have the log base 4 of 5 minus the log base 4 of 4. Well, we know log base 4 of 5, it's right here, right? This is going to be approximately a 1.1610. And then we know log base 4 of 4 is a 1 for this same rule that we have up here. So we're going to get that this is approximately a 0.1610. That's it. All right, our very last problem in this video and also this section, go ahead and give the same concept a try. Again, when you're looking at numbers that multiply to 35, pick ones on the table. Here, 5 and 7 are the natural choice. So this is the log base 2 of 5 plus the log base 2 of 7. Well, we know both of those, right? Here's the log base 2 of 7, and here's the log base 2 of 5. So this is going to be approximately 2.3219 plus 2.8074. If we were to add those, because I'm going to be too lazy to type in the calculator. I don't know if this makes me more lazy or less lazy, right? Okay. So it's a 3, carry the 1, 9, 2, 1, carry the 1, 5. There we go. So we get this is approximately a 5.1293. Right? Log base 4 of 60, well, this one's a little bit tricky. So 60, I need to split it into, if you look, 4's because I already have a base 4, and 3's and 5's. So this is actually a 4 times a 3 times a 5, right? Because it's 12 times 5 or it's 4 times 15, any way you want to get there, right? So I'm going to get this is the log base 4 of 4 plus the log base 4 of 3 plus the log base 4 of 5, right? Well, this one's actually a 1, and the other two are approximated on the table, right? So this is going to be a 1 plus, we have a 0.7925 plus log base 4, 1.1610. 0. Now, interestingly enough, you could also notice that we've already done log base 4 of 15. It's a 1.9535. So these two together are going to end up being a 1.9535 because we actually found that in, this was in E6A, right? So if you already knew that, you could have actually cheated instead and said, hey, I'm going to use my own work and make this the log base 4 of 4 times the log base 4 of 15, which is what this would have been. Either way, you're going to end up getting that this is approximately a 2.9535, right? And then for the last one, we have the log base 2 of 2 over 7. So that's going to be the log base 2 of 2, which is a 1, minus the log base 2 of 7, which we have a formula for, right, or a value for. So we're going to get this as a 1 minus a 2.8074, right? So that's a negative 1.8074. And that is it. All right. So that should be an approximate because it's approximate. All right, so that's it for our section 6.4.